computer. Okay, so let's take a look. Last section, guys, we made it. Here we go. And it's about infinity. So every limit dealing with infinity, there's different places infinity can come up. So the good thing is, maybe the end one, there isn't a lot of work, but there's more like thought process. There's a few more things you have to remember. Okay. So last thing on limits carries in just a little bit to chapter 2, and then kind of stays out. Okay. So we're almost done with limits, sections 1.6, and limits involving infinity. All right, so we'll maybe take some notes on the side, but I'm going to start by looking at an example right away. So the directions are going to be find the limit. And the first one is going to be the limit as x approaches to from the right. So there's a little plus sign there. And then it's going to be x minus 5 over x minus 2. Okay, so the title of the lesson was limits involving infinity, and I don't see one infinity symbol. Okay, so what's going on here? So what's left? The answer, right? So the answer is actually going to be infinity, but or negative infinity. But let's talk about, let's just look at this for a minute. Does anyone know, look at this, this is a rational function. And I'm asking for something, don't even worry about this necessarily, I'm asking for something at 2. Who can look at that and know where we're at on the graph? After things got canceled, or there was nothing canceled to begin with, 2 is what makes the bottom 0. So what got crossed out 0 is a hole. What makes the bottom 0 is an asymptote. Okay, so you kind of have to realize that, hey, when you're doing these, hey, I'm at an asymptote. Now, what's going to kind of give it away is the plus or minus. Kind of anticipate when you see that plus or minus that you're at an asymptote. Okay, because at an asymptote, graph is going up, graph is going down. Okay, we're not going to get into where they're going the same direction. We're not even going to get into that. So you can assume that at an asymptote, one's going up, one's going down. So does it make sense that I have to then specify if I want the left side or the right side? So kind of anticipate that when they ask for a left side or right side, and then you can kind of double check, oh, yep, that makes the bottom 0, I'm at an asymptote. So the answer is either, now remember, it's a y value. Our answer is a y value. So what y value are we approaching as we go towards the asymptote? Either positive infinity or negative infinity. So there's not any work, but so far you have to recognize that you're at an asymptote, and my answer has to be positive infinity or negative infinity. So how do you do that? You simply check. Give me, you want a test value. Test value. Give me a number on the right side of 2. It's got to be pretty close because we're talking about right at 2. So I want something like 2.1. And then you simply plug it in. 2.1 minus 5 over 2.1 minus 2. And all you care about, you already know the answer is infinity. Is it positive infinity or negative infinity? So you just test. This is going to give you a negative. 2.1 minus 2 gives you a positive. A negative divided by a positive is always negative. And so you know that it's negative infinity. Maybe I shouldn't put equal. Let's just put a negative there. And then because of that, I know it's negative infinity. But you have to know to do the test point because you have to recognize that you are at an asymptote, okay? Now, if you really get stuck, and I'm okay if you don't want to do this, I will also let you graph it because you're still going to have to know, hey, it's at the asymptote, and is it going up? Then it's positive infinity. If it's going down, then it's negative infinity. And you have to pick the right side, so, or the correct side. Okay, so let's try another one. What do we think? Again, there's not a lot to show, especially if you're going to graph it. That's okay too. But you're going to have to think about, or you're going to have to recognize. Maybe that's a better word too. The limit and x approaches. Now, just be careful. -4 from the left. X plus 2 over x plus 4. Just be careful on the homework and on the review sheet and on the test. You got this arrow, then there's a minus, and there's a minus there. So really take an extra second to recognize it. Is it -4, is it +4? Am I coming from the left or am I coming from the right? Okay, on your own, that'll kind of give you a clue. Remember, because they're only asking for one side. They're asking coming from the left. And sure enough, -4 makes the bottom 0, which means we are at an asymptote. You kind of have to do that, recognize that on your own. If all of those make sense, then you know you're going to do a test value, because as soon as you recognize that you're at an asymptote, your answer is either positive infinity or negative infinity. Okay, the y value is either going up. So it can be this situation. It can also be down this way and up this way. Does that make sense? We still have to test it because we're not sure which side is doing which, but we know it's going to either positive infinity or negative infinity because you're given the y value. Remember, the answer to the limit is a y value. Okay, now just take your time here. Here's -4. You want something on the left. Be careful with the negative. You don't want to know that you do a test point and then pick the wrong one. So what would be to the left of -4? Something like -4.1. -4.1. So just take your time. Make sure you get something to the left. And then you just simply plug it in. You can come up with a number, but main thing is we just care if is it negative or positive. So -4.1, -4.1 plus 2, and then -4.1 plus 4. So that gives us what? The top will be negative. I mean, you can do the arithmetic, but main thing is it's a positive or negative. The bottom will also be negative, right? Whichever is bigger, right? When you're adding and subtracting, whichever is bigger. So negative divided by negative is a positive. So I know that it's headed to positive infinity. Let's do this one. It's kind of like 3 types. So this will be the first type. This one might be the hardest, and something like that is what's going to be on the test. But let's just talk about the limit as x approaches -1 from the right. X squared plus 7x plus 10 over x squared plus 3x plus 2. So I don't really know where I'm at here. I mean, most of the time, I mean, I can ask for a left side or right sided limit, even though I'm not at an asymptote. That is doable. But most of the time, that's when we specify left or right. Okay. So right now, just seeing this, I'm kind of anticipating that they're talking about an asymptote. I can ask about a left or right side at anywhere, anytime I like. But usually we do it at an asymptote because that is really one-sided. So how could I know for sure? What would I have to do? To know for sure, I'd have to factor. Let's factor it. Let's see. What multiplies to 10 and adds to be 7? X plus 5 and x plus 2. And then what multiplies to 2 and adds to be 3? X plus 2 and x plus 1. And this will be kind of good review too. So what's happening here? What makes that 0? So at -2, I have a whole. And then what makes the bottom 0 after crossing everything out? -1 would be, in fact, the asymptote. Since I did all this work, I might as well use this guy. I might as well use x plus 5 over x plus 1. If for some reason I want to go back to the original, I can. And the only difference between this one and this one is the whole. So if I'm not talking about -2, they're the exact same graph. And even if I am talking about -2, what's the first thing I want to do? Fill that hole in anyways. All right, so now just take your time. What is to the right of -1? What would actually be to the right? Something like -0.9? Something like that. Do we see how that would work? -0.9. You must have been pretty close. All right, so that, and then you just plug it in. Remember, this is our test value. Because now that I know I am definitely at an asymptote, what's my answer? 50-50 chance, positive infinity or negative infinity. Okay, and even if you put that down, I'll give you partial credit because you tied a lot of that stuff in. Okay, you knew you were at an asymptote. You knew that at asymptotes it has to be positive infinity or negative infinity. If you want to graph it instead, that's okay. That's more than fine. -0.9 plus 5 and -0.9 plus 1. So that gives us what? Positive and positive. So it is in fact going to positive infinity. All right, so that's the first. Remember the title was limits involving infinity. So the first situation is you're at an asymptote and it's the answer that's infinity. All right, the next one, the next kind of type, we have to talk about, we like polynomials. There's a lot of consistency. Anyone know if it's a positive x to any even number? The ends of the graph, are always going to be the same. Think of a parabola, because that would be a positive here and an even number. That would be x squared, right? What do the ends of a parabola do? You go up. And so all we care about, we're going to care about the ends of the graph. If it's an x to the fourth, does anyone know what an x to the fourth? An x to the fourth can look very similar to a parabola, but it can also look like, and you don't necessarily have to write this down, this would be like a parabola. An x to the fourth looks something like this sometimes. An x to the sixth has one more bump. Any even power, though, is going, both ends are going up. I mean, we don't care what's happening in the middle, at least for limits. In this situation, how do we get them both going down? No. Think of how do we get, does anyone know a parabola going down? So it's still going to be x to an even number. Anyone remember how to get that going down? The coefficient is negative. Right? So if you have a negative out here, going down. Yeah, don't hesitate. You can say it. You're wrong, doesn't matter. I took traffic school once, and the teacher was like, we don't judge. Well, I got to take it down and judge something. All right, so for an even number, ends are going down. Ends are going down. Okay, whether it's a parabola going this way, it could be like one of these to the fourth. As long as it's negative and even, we just care about the ends. Okay, now what's our other situation? If the exponent is odd number, and it's positive. You can actually even think of a line, right? Because an x to the first, that would cover it. If your slope, your number in front of your x is slope, if it's a positive slope, this end is going down and this end is going up. Now for a line, these would be more straight, but everything else is curved, so I curved it a little, but it doesn't really matter. We just care if it's going up or down. Does anyone know what a cubic looks like? The most basic cubic goes up the page. So if you, but like I said, you could even do a line because that's an exponent of 1, which is odd. So it still fills it. That's why polynomials are so nice. Okay, with the last, we've got negative x, so an odd number. So just switch. The left side is going up, and the right side is going down. Now we talked about that. Do you remember kind of what cubics? So this would be like an x to the third. If it's a negative x to the third, it would be going down the page. Okay, so let's go back. Let's go do a few more. So this time we're going to find the limit. And the title was Limits Involving Infinity. Now this one's going to stick out a little bit more. So let's do the limit. And this is going to say as x approaches infinity of 3x to the fifth minus 4x squared minus x plus 8. So this one we're going to know is kind of, yep, it's involving infinity because there it is in our limit. And so this time it's going to stick out just a little bit more. The only thing we care about is that term with the highest exponent. So none of this is going to affect the ends of the graph. How do I know I care about the ends of the graph? Because I'm going to infinity. Okay, an x value of an infinity is at the end, right? We can't quite get there, but you get the idea. So if I'm talking about the ends of the graph, I only care about the first term with the highest exponent. None of this else has any impact as far as what is it doing at infinity. Positive and odd, so you just have to remember positive and odd. This is infinity, what would this be? This would be negative infinity, right? Okay, so this one, I'm talking about the positive infinity. What is it going y? It is going to infinity. So remember, you still have to think x and y, right? So I still have to think to the right, and then I have to give it going up, so that's the y value, that's the infinity. Let's do the limit. The limit as x approaches negative infinity of 5x to the sixth minus x squared plus x. All right, so I kind of had to recognize I'm dealing with a polynomial, but I'm talking about negative infinity. What's happening all the way to the left? Okay. The only thing I care about is this first term with the highest exponent. I don't really even care about 5, except I care that it is positive. Okay. So positive, even power. positive even power. Positive even power. Do I want the left or do I want the right? I actually can't go wrong, right? But technically I want the left, okay? And it is going up to positive infinity. So this says I want the left, and because it's going up, this is left, this is up. That makes sense? Don't forget that it's always going two directions. Yes, it's going up, but I'm also talking about the left side of the graph. You gotta think X is left and right, and then my answer is up or down because my answer is Y. All right, let's do one more. We'll try it without this. How about, let's do the limit as X approaches negative infinity of negative 5x to the third plus 2x squared. All right, so the only thing I care about is I have to recognize, hey, it's a polynomial, so we know what's happening at positive infinity and negative infinity. This negative is talking about the left, and then this guy, what does this negative x to the third mean? Negative x to the third is up on this side, down on this side. Think of a line with a negative slope, okay? Where it's a cubic, but it's going down the page. Negative takes you down the page. So left, because it's negative infinity. And then what is this arrow telling me about the y value? The answer would be positive infinity because it's going up. So again, not a lot of work, and that's okay, but a lot more thought process. Same thing, I'm okay if you graph it. If you really get stuck and you want to graph this polynomial, I'm okay with that. Because you still have to know, hey, this is talking about the left. You have to know that that's talking about the y value. So that would be okay to graph as well. If you forget that little chart, then see if you can graph. All right. Last one, let's on with rational functions, which we were doing earlier, but going to infinity. So let's do this. Last type. Let's look at the limit as x approaches infinity. So now we're doing infinity, 4x plus 5 over 3x minus 2. All right, so we're back to rationals, but we're definitely not at, I'm going to say it like this, we're definitely not at vertical asymptotes, but we're actually at, when we talk about going to infinity and negative infinity, what do rational functions follow as they go to positive infinity and negative infinity? They follow the horizontal asymptotes. And so we're going to try to tie that in. We'll talk about how we do it, but we're also going to tie in the horizontal asymptote. Because think about it, if I'm going to positive infinity and negative infinity, that is end behavior. And end behavior dealt with horizontal asymptotes. So that at least makes some sense. Going to infinity and negative infinity with a rational function is talking about end behavior. End behavior goes with horizontal asymptotes. Okay, so the trick, or what you technically algebraically have to do, is you divide every term, and I'm talking about numerator and denominator. You're going to divide every single term by x to the highest power, x to the highest power in the denominator. This, if you're taking Calc 2, this comes back in the last chapter. You start with this, you finish with this. Different situation, but okay. So let's talk about what that means. What's my highest exponent in the denominator? My highest exponent in the denominator is x to the first. So I'm going to divide everything by x to the first. Every single term, top and bottom, by x to the first. So now let's talk about what we have. We've got the limit as x approaches infinity. What's going to happen here? This first one, the x's cancel. And so actually, should I write that separate? So the x's cancel, so I have 4 plus 5 over x over, here the x's cancel, so I have 3 minus 2 over x. And we just made a messier problem. Whose idea was this? Okay, but this is a good concept that we had to remember. We're plugging in infinity. We're plugging in a really big number. What's 2 divided by 1,000? What's 2 divided by 1,000,000? 2 divided by 1,000,000,000,000 starts to get to be really, really small. The bigger the denominator, the smaller the value. So remember, we're only doing limits. So as this gets bigger and bigger and bigger, what is this overall value approaching? 0. That as the denominator gets bigger and bigger and bigger, I mean, if you do 2 divided by 1,000,000,000,000, it's probably going to give you 0 even on your calculator. You know, I mean, it's just not, even if you round it to the billions, right, it's going to be 0. So these are headed towards 0. The limit, we technically can't plug in infinity because infinity isn't a number. But at the same time, we plug in bigger and bigger numbers, it's headed towards 0. So 4 plus 0 over 3 minus 0 is taking us to 4/3. Now, who remembers, let me rewrite this problem. I think it's on the test too. Who remembers when we were trying to decide horizontal asymptotes? If the exponents were the same, what was our answer? The lead coefficients. Now you know why. We actually were taking the limit. We actually technically were supposed to divide everything by x, and that's where the 4/3 is coming from. That's why we had that little chart. If the exponents are the same top and bottom, the answer is the lead coefficients because of all this dividing. So it's up to you. I'm okay. If you remember that rule and you can just go to 4/3, that's okay. If you want to divide everything by x, that's okay too. Right? Let's practice it though, because they do get a little bit harder. I don't know if the harder one makes the test or not, but okay, so let's do this one. But let's at least talk about it, because like I said, then we got a few harder ones. Okay. Again, I think the hardest part is recognizing when to do it. Like right now, yeah, it's a piece of cake, right? Because that's what the problem is. But let's take a look. The limit as x approaches negative infinity. 2 minus x squared over x to the 3rd minus 2x plus 4. So I have to recognize that I have a rational expression. And this is kind of nice. I have a rational expression. I don't really care if I'm talking about negative infinity or positive infinity. There's one time where we care. We'll talk about that in a minute. But in general, I just care about the end behavior. So when it's irrational and I have positive infinity or negative infinity, I'm really talking about rational behavior, which means I'm talking about the horizontal asymptote. Okay, now if I want to do it algebraically, what am I going to divide everything by? X to the highest exponent in the denominator. So I have to divide everything by x to the third. Everything's going to go x to the third. Cancel if you can. And I'm still doing the limit as x approaches negative infinity. It's going to be 2 over x to the third. Nothing cancels. Minus here an x squared would cancel. So I have 1 over x. And then on the bottom I have 1 minus 2 over x squared plus 4 over x. You officially made it messier. But that's, believe it or not, that's okay. So not only am I plugging in, oh, actually this was negative infinity. Don't worry about the negative. The negative actually doesn't really hold a whole lot of water. There's one time where it kind of does, like I said, we'll talk about it in a minute, but 4, not only am I putting in like a billion, but then I'm actually cubing it. Okay, even if I'm putting in a negative a billion and cube it. So I'm on one side of the 0 or the other side of the 0, but I'm approaching 0. Okay. Technically, I'm coming from the negative side, but it doesn't matter. So these here, 4 divided by, I mean, I guess you'd say a really, really small number like negative a trillion is still going to be 0. What about here? Same thing, right? 2 or x to the third, 2 divided by, negative a trillion, that's 0. 1 divided by a trillion, that's 0. This stays. These guys are both going to 0. So what do I get for an answer? 0 over 1, which just means I'm approaching, a 0 on top is fine. It means that I'm approaching 0. Go back to that original problem. 2 minus x squared. What was our rule? If the bottom exponent is bigger, my horizontal asymptote is at 0. You know, it all goes together. That's why we like math. There's no surprises. All right. And that'll help, like I said, if you see that and you don't want to do all the dividing, that's okay. These last few problems are a little bit trickier. It probably would help to do some dividing. So let's at least talk about these. All right, we gotta make it a little bit harder. Remember, I said our author loves hard problems. So here we go. The limit as x approaches infinity, he adds a square root. Square root of 25 x to the 6 minus x over x to the third plus 4. I'll hit those look to see if this is on the test. This is pretty detailed. If you can get the other ones, you're going to be in good shape. But yeah.
That's the x to the 6.
Yes. Yes. This is a 6. Yeah. Looks like a swan or something. Does that help? Yeah. Especially people out there. Okay. So let's start with the rule. What's the rule? We divide everything by x to the highest exponent in the denominator. So what would we divide everything by? X to the third, right? Okay. So the problem is I've got this square, the square root. So I really have to do x to the 6 minus x. I have to really divide this whole thing by x to the third. So I really can't go inside there with that subtraction. But here's the trick, how to get it so that I can put it with each thing inside the square root. Make it a square root. What could I change this to so that I can make it a square root? X to what power under a square root would be the same thing as x to the third? Any ideas? Remember, the square root means you got a dividing by 2 as an exponent. And what number can I put up here so that it still equals 3? 6. Yeah, so if I make this an x to the 6th and then take the square root, that's going to be the same thing as x to the 3rd. You have to double it to put it under a square root. But now that it's under a square root, now I can combine this and put it all together. Now I can do, the square root of, it's going to be bigger because now I can bring it in. 25x to the 6th over x to the 6th minus x over x. And then I still have this guy, x to the 3rd over x to the 4th. So the square root makes it a little bit harder. You have to double it and put it with the square root, but that allows me then to put these inside the square root. That's the trick. We'll do another one. Okay, so we're doing the limit as x approaches infinity. Now we're in good shape. So it's going to be the square root. These are going to cancel. So I've got 25 minus 1x cancel. So I've got 1 over x to the 5th. That's all under the square root. And then on the bottom, I've got 1 plus 4x. And so now we're in good shape. What's happening to this fraction? It's headed towards 0. Okay? And this one's headed towards 0 as well. So if you, in your notes, if you want to write 25, technically that one's headed towards 0. And then 1 plus that one's headed towards 0. So the overall limit then is, you see how it's the square root of 25 over 1, which would be okay. Now this is where it gets even a little bit dicier. Let's take a look at the same problem. Well, let's rewrite it, and we've got to rewrite it too. But so it's going to be the limit as x approaches negative infinity. But then it is going to be the square root of 25 x to the 6th minus x. Maybe I should have chosen a different one. But x to the 3rd plus 4. The negative infinity, this is the only time negative infinity and a radical. This is where we have to talk just a little bit more. So I'm going to divide everything by x to the 3rd. And we can write this 25 x to the 6th minus x over x to the 3rd. And then this one will do x to the 3rd. But this step is important here. Right now, remember, technically I am plugging in negative numbers. I'm plugging in negative numbers, so x to the 3rd is going to be negative. But when I change that, 25x to the 6th minus x, when I change this to x to the 6th, the square root, what just happened to all those negatives? x to the 6th is now positive. So that's a huge, that's kind of like a, this is a hard one. If I'm going to negative infinity and I have this square root, I actually changed something from odd to even. And I made all those negatives positive. Now, everything turns out the same. So I would do 25 over x to the 6 over x to the 6. All that turned out the same, but on my own, and actually I could even change this already to 1 and 4 over x. On my own, so these cancel. 25 minus 1 over x to the 5th. And everything else is the same. This is going to 0. This is going to 0. On my own, I have to put a negative because I change all those negatives to positive. So this negative is going with this negative. Now, if it's even, and I would change it to an even, I don't have to worry about it. Does that make sense? If it's going to negative infinity, but I use an x to the 4th, and then I change it to x to the 8th, I don't care. Because the original problem had an x to the 4th, and that would have made it positive to begin with. So the only time is when this is negative, and this goes from odd to even. Pretty, you know, this is a pretty detailed, so don't completely panic. Don't lose sleep over it. But at least you can follow it. This is something, like I said, this would be like a challenge problem. Because I went to odd to even, if it's even to begin with and it's even, who cares? Right? Then I would still just do the positive value, only because I went odd to even. I should write this down. Maybe one day I'll take that out, but that's okay. You guys have benefited from that. What? Okay, let's at least, I think just one more thing. Let's do one more. Last one, here we go. Last new problem for chapter 5. Let's do the limit. Let's do positive infinity so we don't even have to worry about that. X minus 4 over the square root of 5x squared plus 2x minus 1. Now, kind of the same thing. Because it's in a square root, I'm not actually going to divide everything by x squared. I only have to divide stuff by x to the 1st. Okay. If I divide, I'm going to divide this by x to the 1st, this by x to the 1st, and then I'm going to divide this whole thing by x to the 1st. But what is it going to have to become to put it under the radical? I want it to be, so I want my bottom to be a 2 because I want to make it a radical. What does my top have to be so that it still has a value of 1? It has to be 2. So I'm going to change this guy. This will go to 1. This will go to 1. 4 over x. And then this will change. This will stay actually. The bottom will change. The denominator will change to the square root of x squared. What's the square root of x squared? X. But now I can put it under the radical with all the other stuff. So this will change. Don't forget we're doing the limit as x approaches infinity. 1 minus 4 over x. And then we can put it under 1 radical 5x squared over x squared plus 2x over x squared minus 1 over x squared. It's all under a radical. And now we're in good shape. So let's see. We don't have to write it one more time. Let's just write it one more time. This is still good. Square root, this is beautiful, that changes to 5. This is still messy, right? 2 over x, and this is still 1 over x squared. But because I'm going to infinity, what do all 3 of these go to? Those are all headed towards 0. As the bottom gets bigger, the overall value heads to 0. So we've got 1 minus 0 over, don't forget the square root of 5, but those are going to 0 as well. So my answer is 1 over square root of 5. If you make it that far, I'm not going to make you rationalize. Okay, so that's perfect. All right, so give it a try. There's 3 things going on. So remember, we were talking about vertical asymptotes. These here are the horizontal asymptotes and the polynomials. What was happening at the end? Give it a try. Let's see how you do, and then we'll regroup. We can go over questions tomorrow. And then you're going to look at the review Wednesday and Thursday. Let me